Hello, my darlings. Okay, so today we're going to look at an AP differential equation type problem. So here we go. On a certain day at dinner, the total number of food orders taken by time t is modeled by a function f that satisfies the differential equation df dt equals 48 over the square root of 3t plus 1, where f of 1 is 32, and where t is the number of hours since the diner opened, and 0 is less than equal t is less than equal 8. So we have a lot of information in here. Now the first question they're going to ask us is to write an equation for the line tangent to the graph of f at t equals 1. Then we're going to use this equation to approximate the total number of food orders taken by time t equals 2. So first we start with the tangent line. So they want this at time 1. Now to find the matching y value, we need f of 1, which was given to us up here. That's 32. Now the slope of the tangent line is the value of the derivative evaluated when t is 1. So that means 48 over the square root of 3 times 1 is 3 plus 1. So that's 48 over 3 plus 1 is 4, the square root of 4 is 2, and that's going to give us 24. So our tangent line is y minus the y value 32 equals the slope 24 times the t minus the t value of 1. Now, if we want to approximate the function, that means that our function is approximately, I'm going to bring the 32 to the other side, 24 times the quantity t minus 1 plus 32. Now we can use this to approximate f of 2, which would be 24 times 2 minus 1 plus 32. Well, 2 minus 1 is just 1, so this is 24 plus 32, and that gives us 56. So we just found that f of 2 is approximately 56. It's not exact, which means that about 56 food orders at time t equals 2, okay? And that's what that means. So there's about 56 food orders at time 2. Okay, let's see what they have in store for us next. Find the second derivative of f evaluated at 5. Using correct units, interpret the meaning of f double prime of 5 in the context of the problem. All right, so remember, this df dt, that's really just f prime of t. So we know that f prime of t is 48, and I'm going to rewrite this as 3t plus 1 raised to the negative 1/2, right? That's why it's in the denominator with the square root. The negative puts it in the denominator, the 1/2 is the square root. Now we're going to take the derivative of that so we can find the second derivative of f. So we do negative 1/2 times 48 is negative 24. We keep the inside. We decrease the exponent by 1, so that's negative 3/2 times the derivative of the inside is 3. So that means that our second derivative is 3 times negative 24 is negative 72 times 3t plus 1 raised to the negative 3/2. Okay? So now we can find f double prime of 5, the second derivative of f at 5. So that's going to be negative 72 times 3 times 5 is 15 plus 1 raised to the negative 3/2. So this is negative 72, and we have 16 raised to the negative 3/2. Now the negative tells me to put the 16 in the bottom. The 3/2 tells me to take the square root and cube it. So I still have negative 72. The square root of 16 is 4, and I have to cube that. And 4 cubed is 64. So negative 72 over 64. 8 goes into that, negative 9 and 8 times. So we have that the second derivative of 5 is negative 9/8. Awesome. Now we need to interpret that. So remember the nut. You need the time, you need the noun, and you need the unit. So when is this happening? At time t equals 5, and we are in hours, right? 5 hours. Or if you want to get some more specific, you can say 5 hours after the diner opened. Okay. The rate at which food orders are taken right? Because f prime was the rate at which food orders were taken, but now we took the second derivative, and that is changing, or is decreasing because it's negative, is decreasing at a rate of 9/8 orders per hour Okay, because remember the rate of change, the unit on f prime was orders per hour. Then we took the derivative again with respect to time, which is why it's per hour. This is our interpretation. Whew. Okay, we're still not done. Now we're going to find an expression for f of t. Based on this model, what is the total number of food orders taken by time 8? Okay, first thing, there's more than one way to do this problem. Since we're in the differential equations unit, I'll start with that method. So we start with our differential equation, df dt equals 48 over the square root of 3t plus 1. And we separate our variables. So the t is going to go to the right, and we have no other f's to move. So we have df equals 48, but I'm going to rewrite that over the square root of 3t plus 1. I'm going to rewrite that as the quantity 3t plus 1 to the negative 1/2 again, but I multiplied by my dt. And now we're going to integrate. All right, the antiderivative of df is just f. The antiderivative, on the other side, we're going to keep the 48. We're going to keep the inside 3t plus 1. We're going to add 1 to the exponent, which is 1/2. We divide by that exponent 1/2, which is really multiplied by 2. And we divide by the derivative of the inside, which is 3. And don't forget, we have to add a constant. So now we know here that f of t is now 48 times 2 divided by 3. That's 32. And we have the square root of 3t plus 1 plus c. Okay? We're going to use the fact now that we know that f of 1 is 32. That way we can find our c. We know that f of 1 is 32. So that means 32 equals 32 times the square root of 3 plus 1 plus c. So 32 equals 32 times, now 3 plus 1 is 4, but if I take the square root, that's 2. So 32 equals 64. Our constant is negative 32. So now we know that f of t is 32 times the square root of 3t plus 1, and then outside that square root, minus 32. So now we have our function of f of t. But they also wanted us to find the number of food orders at time 8. So I'm going to do f of 8. Okay, so there we go. So f of 8 would be 32 times the square root of 3 times 8 is 24 plus 1, and then minus 32. Well, 24 plus 1 is 25, and the square root of that is 5. Okay, so 32 times 5 is 160, minus 32 is 128. So now we know that f of 8 is 128. Ta-da! Now there's another way to do this. This method goes back to the fundamental theorem. Remember that this is just f prime of t. So we know that f prime of t is 48 over the square root of 3x plus 1, and we know that f of 1 is 32. Well, that means that we can find f of t by using our initial condition where the y value is 32 plus the integral from 1 raised to t of our derivative, but this time I'm going to write the derivative in terms of x. 48 over the square root of 3x plus 1 dx. And guess what? That is your expression for f of t. So we didn't have to do the antiderivative to get the expression. However, we are going to have to when we want to find f of 8. So now that we want to find f of 8, that's 32 plus the integral from 1 to 8 of 48. And you know what? Here I'm going to rewrite that 3x plus 1 raised to the negative 1/2 again, dx. Okay, so that's going to be 32 plus, and now we're going to take the antiderivative. We keep the 48, then we keep the 3x plus 1, add 1 to the exponent, so it's 1/2, and then we multiply by the reciprocal of that, which is 2, but don't forget the derivative of 3x plus 1 was 3, so we have to divide that out, and we're evaluating from 1 to 8. So that means we have 32 plus 32 times the square root of 3x plus 1 evaluated from 1 to 8. So we have 32 plus 32 times, and we substitute in the 8. 3 times 8 is 24 plus 1 under a square root minus the square root of 3 times 1 is 3 plus 1 under a square root. So now we have 32 plus 32 times 24 plus 1 is 25, and the square root of that is 5, minus 3 plus 1 is 4, and the square root of 4 is 2. So we have 32 plus 32 times 5 minus 2 is 3. We are at 32 plus 96. We have our answer 128. So notice very different methods, but the exact same answers. See, there's more way to get from here to the mall. There's more than one way to solve a problem. All right, guys, have a wonderful day. Bye.